Graph the given quadratic equation f of x equals 3, parentheses x minus 2, and x minus 4. That's already in intercept form. So right here, if you notice, we got x minus 2. If we set that equal to 0, we know our x-intercept is going to be the opposite of negative 2, which is 2, 0, and opposite of negative 4, which is 4, 0. Remember, it's always opposite when it's inside parentheses. So you see our x-intercepts right there. Now, we have to put this in vertex form, so we locate our vertex after we put it in our calculator and graph it. Notice our vertex is 3, negative 3, which that's h and k. Our vertex equation is y equals a, parentheses, x minus h squared plus k. Notice I have a negative on h. So remember, it's opposite. So we got a positive 3, which is going to become a negative 3 inside. Now, the y value there is negative 3, so we're at minus 3 for our y value. So right here, we can also locate how much it's stretched, so we can count up. 1, 2, 3, and over 1, so we know it's been stretched by a factor of 3 over 1. Also, you locate this right here. This is your A in your vertex form. Your intercept form. So therefore, that's the same A in our vertex form. Now, to get to our standard form, you can distribute 3 into x minus 2. Distribute 3. I get 3x minus 6. And then I'm going to distribute the 3x into x and negative 4. It gives me 3x squared minus 12x. And then I'm going to distribute negative 6. Negative 6 times x, negative 6x. Negative 6 times negative 4 is 24. Combine my like terms. I get negative positive 3x squared minus 18x plus 24. So that tells me that my y-intercept is going to be positive 0, 24. Alright. Now we'll look at the same graph. And we're going to look at the x-intercepts. Again, it's in intercept form, so they're just the opposite. So instead of negative 2, it's going to be a positive 2 because it's inside parentheses. Instead of a negative 4, it's going to be a positive 4 because it's inside parentheses. So there's our x-intercepts. Our y-intercept, you can't see it on this graph, but if you look at the standard form, you get 3x squared minus 18x plus 24 plus 24 shows us that that's our y-intercept. Interval of increase, x value that it starts at is 3 and goes to infinity. Interval of decrease goes from negative infinity to 3. Alright. Positive, our positive values. Alright, our positive values are the ones that are above the x-axis. So that interval is going to be from negative infinity to the x value right there, because that's where it stops, and that's positive 2. And from 3 to infinity. Now, not 3. From 4 to infinity. So our negative intervals from 2 to 4. Our minimum value is -3. We do not have a maximum. Axis of symmetry is x equals 3. And notice that as x goes down, y goes up. As x goes up, y goes up. Alright. So we've looked at the different forms. We've also looked at the characteristics of our first function. Now let's look at the transformation. And notice I've graphed x squared in black, and I have graphed our function 3 parentheses x minus 2 and x minus 4 in red. Alright, so we're going to look at this and see what has happened. Now you can tell a good bit just from the functions. Alright, now we know that this thing has been moved down by 3 units. Alright, because we can look at our graph and see that it is moved down by 3 units. If we go back and look at our different functions, you can see right here, using our vertex form, you can see that we're going down. Our k right here is moving down by 3. You also notice a -3 here inside, which is going to tell us that it is moving to the right because it's opposite in the parentheses. So we can tell that it's moving down by 3 from our vertex form. Alright. And we'll just go ahead and write our vertex form right here so you can see it. Alright. So, and also, it's moving down by 3, has a horizontal shift by 3, it's +3, because we moved right, we know that's opposite, and it has a vertical stretch by a factor of 3. Now one easy way to look at it is you can see this goes up 1 and 1. This goes up 3 by 1, which tells me, since it goes up by 3 and 1, that it's stretched by a factor of 3. And I also notice the stretch because my 3 is on the outside of my parentheses in every form. Alright. Moving on to the next one, station 4. Alright, in station 4, I graph my equation. F of x equals -x squared plus 4x minus 5. That's already in standard form. Alright. Now I'm going to put it in vertex form. I'll locate my vertex. It's 2, -1 for h and k. So right here, and I also know that it has been flipped over my x-axis. I also know that my a right here in front is negative. So that is also, I have a -a in here, which is a -1. So in this one, my a is also going to be a -1. Alright, and I know that it's a +2, so we write 2, so that needs to be opposite in my function. That's why I have a -h. And I went down 1. Alright, and my y right here, or my k, is -1, so that's going to be right there. Now my intercept form. If you notice, I don't ever cross the x-axis. So if I don't ever cross the x-axis, I can't have an intercept form. If you notice right here, there's no way that I can get two numbers here that give me my that will work for my function here. I know that 5 times 1 is, or 5 times -1 is 5, and or -5 times 1 is -5, but if I multiply this, I will never get back to my function here, because if you look right here, I get x times -x is -x squared, x times 5 is 5x, -1 times -x is x. That's 6x. 5x plus x is 6x. So therefore that won't work. Alright. Now if I make 5 negative and leave 1 positive, that's going to give me negative 5x and negative 1x, which gives me negative 6. Again, that's not a negative 6. That 4x is not a negative 6. Alright. Now, I could try making both of them negative, but I know there that negative 1 times negative 5 is not negative 5. Alright. So there is no intercept form for this function because there is no x-intercepts. Alright, our key features here, there's no x-intercepts, it never crosses the x-axis. Alright, my y-intercept is 0, negative 5. We can see that right here, 0, negative 5 is our y-intercept. Our interval of interval of increase. We look right here, my line's going up here. Alright, it stops going up at positive 2. So I'm going to have negative infinity to positive 2 for my interval of increase. Okay. My interval of decrease. Alright, it's going down from 2 to positive infinity. Okay. Now my positive values, if you notice here, there are no numbers up here above the x-axis, so therefore there will be no positive intervals. Negative, all my values are down here at the bottom. So they're all negative from negative infinity to positive infinity. Alright, I do have a maximum because my graph is going down. My maximum would be y equals negative 1. Okay. So you see my y value there is negative 1, and that's my maximum, that's my highest y point. My axis of symmetry here, alright, is x equals 2. That's where it goes through it. My end behavior here, as x goes to positive infinity, my y value is going towards negative infinity. As x goes to negative infinity, my y value is also going to negative infinity. Alright, now we're going to look at our transformation, basing everything off our parent graph, y equals x squared. So if we look at it, just looking at our equation here, we can see that it went down 1 and over 2. Alright. Now, if we look at our vertex form of this, we can see, we know it flips, so there's going to be a negative for our a value here, just like there's a negative for our a value in our standard form function. So that's a. There's always a of x squared. Now, we also already did this, so we know that this is going to be minus 2 squared minus 1, because that's our vertex, because we know our vertex is 2, negative 1. Now, our vertical shift, we went down by 1. We know our k value here tells us we're going down 1. We can also look at our graph here and know that it went down 1. Alright, we also see that it has a horizontal shift. It went to the right 2. We know that our k here in our function is always x minus, well, it's our h. So that's going to be the opposite of whatever's in that parentheses. So we're right by 2. Alright. A negative a causes the graph to flip over the x-axis. Alright. Station 7. We're giving the vertex form. Alright, I graphed it. There's our vertex right there, h and k. We already have our vertex form. We write it right here. Now, I graphed this one. I said I have x plus 5 squared minus 4. So right here I do x plus 5 squared, the same thing as x plus 5 times x plus 5. I set up my opponent square. X times x is x squared. X times 5 is 5x. 5 times x is 5x. 5 times 5 is 25. Combine my like terms. 5x and 5x give me 10x. plus 25. I cannot forget about my k here, so I have to subtract 4, and I get x squared plus 10x plus 21. Alright, that's going to be important to remember in just a moment. Alright, so next I got to find my intercept form. Now I can look at my graph and find my intercept form as well. I say that my x-intercepts are -7 and 0, and my x-intercepts, other x-intercept is -3, 0. So we know they're always opposite inside our parentheses. So all I got to do is flip the sign and put them in my parentheses. So right here I just change 7 to a positive, change 3 to a positive, and I have my intercept form just by looking at our graph. Now the other way we can do it is we can put our function right here. So I got x squared and I got 21. So I know x times x is x squared, and I know that 7 times 3 is 21. So I got x times x, x squared, x times 3 is 3x, 7 times x is 7x. So now I got x plus 7, x plus 3, and x plus 7, and this is my intercept form. Now right here on the key features, we've already talked about our x-intercepts. We see them right here, -7 and -3. Our y-intercept, 0, 21. This is where our functions are important. Got x squared plus 10x plus 21. So we got x squared plus 10x plus 21. Alright. Our c there is our y-intercept. So I know that 0, 21 is my y-intercept just by writing it in that form, in our standard form. Now you can also put in your calculator, do an equation, or you can plug in a 0 for your y value and figure out your, plug in a 0 for your x value and figure out your x-intercept, or intercepts. So we could also plug in a 0 here, plus 5 squared minus 4. So I can add 4, 4 equals x plus 5 squared. So I got to get rid of the squared. Opposite of squared is square root. Alright, that gives me a positive and a -4. So I have two equations to set up, x plus 5 and -4 equals x plus 5. Alright, so I subtract 5. Alright, so right here I'm going to get excuse me on that last one. I meant the square root of 4 is 2. It's a positive 2 and a -2, so I subtract 5 from 2. So I'm going to get x equals -3. And I subtract 5 from -2, and I'm going to get x also equals -7. So I can solve it by plugging in 0 for our y value, or f of x. Now, I can get my interval of increase and decrease here. So we're going to look at our interval of increase and decrease. So we see that our interval of increase is going up right here. It starts at our vertex point, or h, alright, at -5, and it goes to infinity. Our decrease interval goes from -infinity to -5 again. Alright, that would be our interval of decrease. Positive and negative, so let's look at this one, our positive and negative intervals. So notice that this is above and this is above. the x-axis. All those are positive values. We know up on our y-axis is all positive. So our interval there, one of our intervals is going to be from negative infinity to -7, because that's where it stops going, being above. And our other interval is from -3 to infinity. So pretty much our x-intercepts is where it starts and stops, our positive interval and our negative interval. So our negative interval is going to be from -7 to -3, because if you can look here, you can tell that all these values are negative below our x-axis. Now, we find out it's a minimum because it's going, all of our graph is going upward. Okay? So our minimum here, and that's just going to be our k, which is going to be -4. Alright? Axis of symmetry, we see right here. Again, our axis of symmetry is our h value. Alright, which is x equals -5. Our end behavior, if you notice, everything's going up. So as x goes to the left to negative infinity, my y value is going up. As x goes towards positive infinity, our y value again is still going up. Alright, let's look at our transformation here. We have our x squared graph, and we have our, which is our parent graph, and we have our transformed graph, x plus 5 squared minus 4. First of all, we know our k here shows -4, so we automatically know we went down by 4. And we also see the horizontal shift left 5. So what that tells me is that inside my parentheses I do the opposite. I know that's my h value, and I know that my equation once again is -8, so we got to do the opposite. So the opposite of positive 5 would be -5, so we go left 5. And we can look and see this. Let's do each point. So we just said we're going to go left 5 and we're going to go down 4. So let's start with our vertex. If we go 1, 2, 3, 4, 5, and down 1, 2, 3, 4. Just like a slope. So we see we go left 5, down 4. Left 5, down 4. So as you see, we can use that to graph our next line from our parent function. Now, also notice something. We can see that there's not a stretch here just by looking, but we can also say it like this. Go from your vertex to your first point. I go up and over 1. So that's up 1 over 1. Notice right here, I go up and over 1. So this graph is not stretched or shrinking any. Alright, so down here you can look, we have a vertical shift down by 4, horizontal shift, and we left 5 units.